Okay, welcome everyone. Today we are talking about rapid energy and resource modeling in Rapid BIM, GBS, and Insight360. As well, we will talk about space, schedule, and room assigning, and modeling, analyzing, and optimizing loads, and compare them towards carbon neutrality. I have here a given high-rise conceptual mass, as you see, and this high-rise conceptual mass needs to be now located, because in building information modeling it is very important to have from the get-go always to coordinate, to pull in weather data sets from the cloud. And you need to be signed in. So you see, I'm signed in Autodesk A360. That means I'm connected to the cloud, to big engines like DOE2, Enquest, Energy Plus, and other Department of Energy big engines that provide data sets based on the building typology, schedules, etc., and based on collected data samples of the last 10 or more years, connected, of course, to weather stations. So let's go straight to the Analyze button, which pops up like this. And the energy optimization and settings are in this area. Can you all see my mouse?
Yes.
Good. And this one, root analysis, this is more or less for egress analysis and optimization. It's also connected to Dynamo, so we don't use this later on maybe. And then on this side, lighting and solar analysis, this all runs into the cloud. It's called Insight360. As well, the energy optimization here, once we are finished and have set all the energy and resource parameters, then we are going to send this into the cloud. So let's start with the energy settings. So because we have only a conceptual mass at the moment, we are not using building elements or conceptual masses in building elements. Let's pretend we only have a conceptual mass from, let's say, SketchUp, Rhino, or any other software that we placed in mass in Revit. That's another workflow. We have tutorials for that as well. Now, the reason why we only use conceptual masses at the moment is to make it very simplified and easy in the conceptual design stage. Later on, when we switch to space, level, schedule, occupancy programming, then we will select conceptual masses and building elements. It's a new construction. It's not an existing construction. If you click here, existing, then the AI that communicates with the cloud engines will then pull in data sets on default that apply to existing building sets and parameters. So just new construction. You click then the next level, which is editing, and here we have targeted percentage glazing. Now, most of us in professional offices, we are looking up the building code, and when the building code says for high rises or offices, there's only 40% glazing permitted, or it's mandatory, then we have to put in that number. Now the 40% that you see here by default is the average that is chosen already by default by the setting of the software and the cloud. Now it is important that you always click glazing is shaded, because we are in a tropical climate. It's very important to activate that function. Percentage skylight, that needs to be 0 because we are in the tropics. Now Albert and Camilla, they have given you lectures and content about this, so do not activate the skylight. Doesn't make sense in the tropics. Now comes the next data set, the building data. Now, when we open up the building types, these are standardized international building type codes. Every building type that you see here has a set of at least, I would say, millions of parameters, data sets that will be pulled into this Revit cloud modeling. So once you select, let's say, for this high-rise hospital or healthcare, right? It will pull in all the data sets by default. Now, building operation schedule is a very sensible area because this is about how you make a contract to your client. But not that is the major challenge we have here. We also have to, later on, when we do the programming and the alignment of spaces with Miguel, we have to then individually set operation schedules for each space type or room type as they differ. A toilet, one office, or restroom facility differ from each other widely in terms of heating and cooling, dehumidification and air supply, etc., including lighting. So this is very pivotal, fundamental to do the right setting. Now, this is a hospital and healthcare building topology, meaning it's a 24/7 facility. This is the contract, and this is the way you're going to analyze, model, update, and optimize your design towards assembly, manufacturing, etc. If you change it, all values will change immediately. That's not the other ones. HVAC system, keep this as a default. This is a proposal. You can always change that later on in Green Building Studio and Insight360, or your collaborating engineers, MEPs, electrical engineers, etc. They will give you a so-called GPXML data file that you import into Revit or into GBS or into Insight360 to override the data sets of HVAC systems. Same for outdoor air information. Just keep it as it is. 15 cubic feet per minute. It's okay. That's a standard. Just keep it. Export category at the moment are not rooms because we have not assigned any rooms. So we keep it conceptual. This is very important because at the moment we are in the conceptual stage and we do not have yet detailed rooms and spaces as we do it later with Miguel when he takes over. Then the next package is the material thermal properties. Now here it is very, very, very important that every architect and engineer looks at the local building code because that is mandatory. It's also about liability. You cannot change those values, so you need to look them up. And the ones that we have here are by default, but they might not match the local building code. So I'll give you just one example. Let's look at glazing. The Florida building code requires not a double pane clear and no coating. It requires a double pane clear hot climate with a solar heat gain coefficient setting. So you need to select this. This is in the building code. Now, there are better ways to do it later on by just going to the manufacturer webpage and import the Revit family from the manufacturer, because when you do that, then automatically it will override all the settings. And you also have then materials and systems and components that are certified for this local area and has a building code permission. So we just move on because there are more parameters that we can discuss, but this depends on the designs. For example, if you have a lightweight construction, you choose this one with a, let's say, either a high insulation, if there is a LEED certification or living challenge certification involved, and you need to achieve from the get-go carbon neutral or net zero energy settings. So you need to go right here. So it always depends what kind of workflow you're choosing. So let's confirm this. And you see down here in the corner, it's already processing and regenerating the settings. Schematic types, also here, I would not change this. Just keep this as it is. We're going to change this later on when we do more detailing. But you see already here, all the analytic construction defaults are already in this package given to you, the cloud. And again, to be specific, you would have to read the building code and look it up, what the exterior wall needs to have and achieve in terms of U values. And you should already know the difference between U values and R values. As a pop quiz, the higher the R value, the better, or the lower the U value, the better. So that's the formula as a pop quiz. So you would have to read through the building code and make sure that these settings would match your local building code. No? But as for now, because of the constraint of time that we have, we just keep it as it is. Don't click detailed elements as we don't have them yet. And now we just confirm, because this is nothing else than a rapid energy resource modeling workflow in Rapid BIM with GBS and Insight360. So the next step is then you're going back to this window and you scroll over, you see here's optimized and here's energy settings. That's what we just did. And now we are going to optimize. Now this icon here has the function of delete energy model. If you're unhappy with the settings after you visited GBS and Insight360, you can delete your energy model and rerun it. And this icon here says generate. Now, we should not optimize in our first run because first we need to see the results in both GBS and Insight360. So what we're doing here is we're just generating this rapid setting workflow. And what happens is it's now sending all the data, as you see here on the left bottom corner, to the cloud, to the Department of Energy Cloud Engines, DOE2, eQuest, and Energy Plus. And these colors, they are coming from the settings under edit type. You can make them darker or more translucent. I always use very translucent X-ray style color settings because it is great to design and plan in 3D with capabilities to X-ray through the building. Now you're wondering, you might wonder why these floors have these window limitations and these shading systems. This is exactly what we parametrically changed in the energy setting up here, because we said it's 40% glazing only. And even we have here a facade family that is already in place on the conceptual mesh, but Revit automatically brings it down to 40%, and it adds automatically a shading system. Now you can replace that shading system with any manufacturer Revit family file, whatever you find on the market and you love it, and the client as well, with this one. But this is exactly the process that happens here in this BIM workflow, that you set parametrically and quantify, analyze and optimize, and then it will pop up on your conceptual mesh. And later on, when you do the elements and components, you can actually go into real world detailing. So you already did lighting and solar, right, Camilla and Albert? So I don't have to explain these functions here. We just go straight to the web page. By the way, there are also other plugins like robot structural analysis, as you see here. This is something where you can also do a code check, building code check on your conceptual mesh, and then you can apply any kinds of structural systems, elements based on span tables. It has also sliders for hurricane types, tropical storm, etc., earthquakes. All these building code parameters are embedded in this cloud modeling workflow process. Also, I would like to mention that we have many other add-ins. So, for example, this is a very good environmental analysis towards carbon neutrality tool. It's called Cove. It's a plugin, and it runs like GBS and Insight within Revit. And then we have also, it's called Sapphira. This is from SketchUp. It's a plugin. It has also beautiful, compelling graphics and diagrams that would be worth to look at it maybe in another semester. And then coming up, this is a beta version. This is Rhino VIP. This runs inside Revit, but at the moment we only have a beta version, and we are in an experimental test phase to find out where the problems are and give McNeil feedback so they can improve this add-in towards a more professional and compatible workflow. With this, let me go to Green Building Studio. So this is Green Building Studio, gbs.autodesk.com. This is now a cloud platform. We are not anymore directly connected to Revit. We are completely in the cloud. And you see here that our twisted high-rise, if I'm correct, we have March 11 today. Is that correct? Hello? Albert? We have the 12th? So it's still running. So let's take just this one from yesterday. So when you click on it, you will see then all the runs. We have in total here approximately 250 runs. And you see all the details of this conceptual mess based on ASHRAE standard 90.1-2010 have been executed, have been done. And it's quantified. All walls, all components by default are quantified. And it runs also automatically with quantifying the square footage. It quantifies the energy use intensity in kBTU per square footage a year. You can, of course, change your preferences to metrics. But this is all done in seconds. So you don't have to use any calculators as I had to do it when I started in your age. I had to do all hand calculations, which took a month. Now this is all done in seconds. And it runs also automatically a cost and life cycle engine, as you see it here in dollars. You can switch that to euros, etc., depending where your project is. What we don't have at the moment is the carbon emissions in tons. This is something that we would have to export from Revit and then import. So you go to, do you see the Revit file? Albert and Camilla? Yeah, you go to export and then you choose GBXML file, and you would export the Revit file as a GBXML file and then re-import into GBS. Now that workflow, we have an extra tutorial for that, and we will provide that to all of you. It's already on some D9 Canvas Studio modules posted already. Also, I forgot one thing to mention, and I'm sure Camilla and Albert did that already. Before you start any project, you always have to first set the location. Without having set the location correctly in this Google map, you won't be able to pull in precise data from the weather and the site. Now, these icons, they have two meanings. I'm scrolling over. This icon, if you see the mouse here, these are the weather stations. And they have all an ID. They have weather stations ID. This is a liability contract. And if your site is somewhere between, as it is right here, as you see, then let me make this bigger. It's easier to see. Okay, now we see it much better. And then we zoom in. So the weather station that we are using here must be the closest one, which is this one. So this weather station has the ID 1050268. This is important because all the participating and collaborating engineers in this integrated project have to use the same weather station per contract. If they use another weather station somewhere out here in the ocean, all your analysis, modeling, and optimization data will be false, will be wrong. That's a big problem. So always have a contract which weather station you're choosing. Plus, click the daylight saving time. There are countries in the world that do not have daylight saving times, but we do have, so we need to click here and then just say okay. So that's actually the first step we always should focus on. Now, the information about the weather station is then in detail documented here in GBS, and this is in particular very important as you have to look for, in this case, for wind diagrams, and you can switch between imperial and metric. It will readjust automatically, and then you can look at the seasons: winter, spring, fall, summer. You can manipulate the hours. You can set certain hours. You can also manipulate the duration. And it will give it to you based on the weather station data sets that are collected in the last 10, 20 years. In general, for energy resource simulations, analysis, and benchmarking, per law and per code, we are mandated to use at least an average of 3 years weather data collection for any site that we are planning on. So that's the building code, pretty much. Now, these data sets are very important for you in terms of setting the baseline templates in the wind tunnel in Autodesk Flow or Autodesk CFD or any other Revit compatible computational fluid dynamics software that needs to be related and referenced to this weather station ID and data. You cannot skip this, otherwise all the flow and CFD simulation you perform are completely useless because they do not have any reference. They have no quantification, they have no evidence. So make sure you have that. So let's go back to the run list and let's click again on the twisted high-rise right here. It's called the base one because the base one for us is very important as it is referenced to the Florida building code. And you all know through the lectures that you heard in D9 and maybe in D7, D8, in Environmental Systems 1, and again in Environmental Systems 2, the American Institute of Architects is striving and mandating carbon neutrality, carbon neutral building design. And so does the United Nations and many countries in the world to reduce greenhouse gases and to strive to make countries, cities, infrastructures, building operations carbon neutral. So that's why we always use a base run. This is our base run. This is pretty much the Florida condition. And then we can create design alternatives and getting to this area later. And then we have here the carbon footprint. Again, the carbon footprint at the moment, we would have to import the GBXML file to populate this window on this side. And every time you work with Revit or GBS or Insight, you need to understand that it's also an educational tool because it always has a disclaimer and a reference. So get used to look at these information signs like here, and then explains how the base run carbon neutral potential assumptions are programmed and how are they broken down. And it also describes the typical definition of elimination or offsetting of fossil fuel on that site and gives you a quantification what's possible. So always look at these assumptions and disclaimers. Here, for example, it has a breakdown of the Environmental Protection Agency Equidata, which is a geographical information system that pulls in the data on a daily basis. So I want to go very quick to to those chapters here, and Camilla and Albert will then later and during the semester talk more about this in detail. So today you just get a very quick overview. So we also have options to look at water usage, photovoltaic, leadership in energy and design, daylight certifications. We can here use VRML views. We can export and download data files on a GPXML format from other software and override our assumptions here in GBS or in Insight or in Revit from engineers or other architects and other software platforms if they are GPXML compatible. So when we look at the water breakdown here, what the cloud analysis and modeling for the Department of Energy does here is it automatically calculates the total water usage for this conceptual type for indoor and outdoor and net utility, and it sources always the building code. It's always with you, no matter what. Even if you look at the building summary down here, it calculates automatically how many toilets we need and broken down for males and females, urinals for this building, sinks, etc., etc. And then it has here a source of the uniform plumbing code where these data sets are coming from. And all the data that you see here, unit water prices broken down in dollars for water and sewer, this all comes automatically from FBL. Now, it also counts the people automatically, as you see here. Right now, it says the typical people for this building type size is 1,552. However, because we selected a specific building type, it breaks it down to 1,441. And this number will change dramatically when we adjust, we go back to Revit and adjust this setting, which is an office setting, back to the hospital setting, as we did it at the beginning of this workshop. This number would go up dramatically. You would have then suddenly 2,500 people in that building type, and the percentage of occupancy would be then 100% because we selected 24 hours, 7 days. Now, to optimize this, it's very quick and playful. So we can say, okay, for this office building type, we take low flow, no, actually waterless, why not? Hands-free, low flow, standard we keep, cooling towers we keep. Then we go to net zero measures. We do harvest rainwater. We do have natural vegetation landscaping. We do collect, clean and reclaim gray water. And we have site portable water sources because we make drink water. It already calculates the rainfall automatically coming from the weather data, so you don't have to look up books and go to the library and use hand calculators. This is all done in seconds through the cloud. It also calculates the catchment area, and then you can also adjust surface types, etc., etc. And then when we go up, you see here the breakdown of the totals. At the moment, we are by 9,255.472 million gallons per year. And here we have the price tag. And then you need to click on estimate. And we are down 3 million gallons. It's a lot. It's a lot of money too. It's about $22,000 less. Always save. Do not forget to save. Save it. And now it's in the data set. It's embedded. So these are the playful ways to go through. Now the same is happening as well for the energy and carbon results. So what you can do is you click here on design alternative. And I make this very short because we have right here where my mouse is circulating, we have a design alternative. This is a tutorial. You need to click here and watch it maybe 4 or 5 times and try to understand it, but it's very easy. What it does is it gives you all options right here broken down and quantified. For example, let's say we're looking for lighting. So you click here on lighting. And then you see here the windows popping up for lighting efficiency. It gives you the lighting power density, gives you the lighting control, etc., etc. Wherever you read default, default, no change, default, no change, do not try to manipulate that, because this is what we have done in the energy settings before. In particular occupancy, this is a mass run parameter, it cannot be edited. We need to keep that. It's like a contract, because we said it's 24 hours by 7 days for the hospital, and for the office it's less. It's 6 days or maybe 5 days and 8 hours. So we cannot change that. That's the contract. Now let me show you when you start to change. So first thing, let's go to lighting controls. I want to show you lighting controls. It is always good to have an occupancy sensor and a daylight sensor in your spaces of an office. Even it's better to have an occupancy daylighting sensor and a control. So you click here, and then it pops up here in red. You see that? It's in red. Everything you update and change here parametrically will be listed in red in the base run. So if you populate all the updates here and you have many red choices, it's important that you then type in lighting, because it's a lighting optimization. Add the alternative, run the alternative. No? If you don't click, it will not run. So now it's running. So these are the settings, how you can optimize towards carbon neutrality. Now, that, yeah. Okay. Let me go down to double check my connection. It looks 80 megabyte per second high. Yeah, very good, yeah, because we are in a state of emergency. Many people are working online now from home. Okay, so while you are populating and updating the GBS data sets here, which is much, much more analytical than Insight, you can also go to Insight. So you click here and then we go straight to Insight, which is a very playful interface with sliders. We're getting there pretty soon. Now there's another pop-up. It's called Project Solon. Now the Project Solon is a beta version. It's the same like Rhino VIP.
So basically we will work a little bit through assigning rooms, spaces, and then do the space setup for the analysis. Basically we have this volume, this high rise. We want to focus on one level, which is going to be level 3. Here we have a small basic subdivision just to be able to show some of the issues you may encounter, or how we probably this will be done. First of all, one of the best things of start doing this assigning, room assigning and space assigning, it's by the tool rule. Even if you are not going to use specifically rooms, you may want to start assigning the rooms and then assigning the spaces to those rooms. That's what we're going to walk through a little bit here. Here, it's automatically assigned, so you don't have to like really do a lot of things. I'm just going to assign some rooms here. As you can see, it has a generic name, and then it's assigning a number for that specific area. Now, once we put it like this, then the next step is to come to Analyze. And here in Scale and Quantities, we can create a room schedule here. This schedule is just going to be used for organization at this point. And here we add the name, the number, then some area just as a reference, and the level where it is. And we have this small schedule here. So now you can open this window here from Revit and assign a specific name to room 1. In this case, this is going to be a presentation area. And the room 2 is going to be a storage. Room 3 is going to be a common area. Room 4, office 1, and room 5, office 2. You can change it by the label, but at least with this is easier. You don't need to start. I mean, for changing in the label, you will have to click on it, then wait for it, change it, click out. In this sense, it's easier to just change it on the room schedule, and then from there it will automatically update on the other spaces. Okay. Now that you update the schedules, you can do it by the tag, or you can do it by the room schedule. We should add the spaces. So the best way is just click here and analyze space. I need to load one. It's probably going to say this to you. And it will take you to a window. I don't know if you guys can see it. Wait. Where you basically will need to add from annotations space tags. Great. Well, okay, but anyway, you can start adding your spaces here. Okay, and now that I added them, I can come here to this tool, space naming, and it will automatically assign the same number and name from the rooms to the spaces that share the same area. So we go here, we click, and it should be done. One important thing here is that if you are adding ceilings, you may want to add a section and check this. So the ceiling is here, and my room, it's up, like all the way up here, and my space too. So
which will be not correct, because only the air volume will be conditioned.
Exactly. Once that you're gonna do the analysis of the heating and cooling loads and what you need for cooling the space or heating it, the proper thing to do is actually take this here until the ceiling. In this particular model, it's a little bit harder to do it because of the shape of the building. If we have these specific areas, it's going to be harder for Revit to assign the spaces to those angles there and adapt to that surface. So we need to do it a little bit by ourselves and adapt it to here. Okay. The next one is we should be checking other ceilings. And other sections. If we come to level 3 again, we have this section here. And here we can see that this is our ceiling. and it's happening the same. So what we need to do is reduce it. This will reduce the cubic feet that are going to be analyzed later on. From here we should go. So okay, now that we finish the spaces and we set this up, we can come here again. We have our areas assigned. We should go to heating and cooling loads, where we're going to start working with those specific conditions. So everything will be loaded as your energy settings. Here we can see how these areas are assigned. So as you can see here, it's taking all these spaces and everything is working properly. If it doesn't, you will have a warning sign on these names. But as for now, everything is pretty much good. And here we go to presentation, and then we should start showing the space type, which in this case is going to be audience seating area, and it can be something close to an auditorium, which is more or less the same usage. Then you start seeing here that where the area per person is. You should check this always up with the International Building Code and the properly codes of fire protection fire protection codes. Here is the
can I just add something? And when we look at the occupancy schedule, this is now a retail facility. You see the retail lighting and other parameter settings. Now these values can be changed, but they can only be changed when the client, the owner of the building, let's say the engineers that are calculating and procuring those systems, agree with the change of the settings. You just cannot do this on your own. This needs to be approved by everyone that is integrated into this planning process. Because if you change the occupancy schedule, lighting schedule, and the power schedule, then you change pretty much the occupancy certification that is issued by the city department. And that would be illegal. So this is why this workflow that is Miguel showing is so very, very important.
Yes. The thing is, for getting this proper way and getting the results that we need to assign a specific, for instance, HVAC system to a space, then we will need these elements to be very exact. In this case, we are assigning to rooms in a specific, so we could be even more exact to what the information that we are setting. In this case, it's an auditorium, and we are adding we are saying that its occupancy is going to be from 7 a.m. to 8 p.m., which is not necessarily the case. So we could create a specific time here on this window where we could reduce the amount of hours daily and create an average, like 3 hours a day. But that's basically another topic. You could do the same with the lighting. You could do the same with the power schedule. It all depends on the processes and the actions that is going to be, that the usage that the areas are going to be having. For now, we're just going to take this information and select audience seating area, like an auditorium. Okay. Construction type, we're going to leave the building one. Here's the people and the area that they are occupying, and the electrical loads and power. If we go to storage, we could check here and look for a storage. Wasters. So we maybe should just look for something similar. Inactive storage, here it is. So you see it's already updated different elements.
And Miguel, can you go back to that building type and schedule? Here we see a much more detailed space type setting for each occupancy type that is referenced to the International Building Code. So that's what we meant before when we did the conceptual energy settings, which is much more, as the word says, conceptual. Now here, finally, we can really go into the details and be very specific.
At these points, when we assign spaces and rooms, we are also seeing the proper materials that are being used on the building: glass, walls, drywalls, concrete. All of this is taken into consideration.
It's fantastic because this gives you pretty much power over the entire process, and this can be shared with any engineer, or even they can help you to edit these data sets. They can send you also PBXML formats to override your settings and to streamline and share in real time.
So it's basically very easily to apply to the day-by-day job, especially if you want to have control over the project, or you are the project manager of a specific project, basically.
And Miguel, what is also wonderful about this is if, let's say, one of the engineers or architects has all the administrator rights, meaning if this is in the cloud as a collective master file, we can, let's say 50 people can work on this worldwide. And then the administrator then approves the settings. It says, okay, this is good, it's optimized. And so the master file is always clean and updated.
Yes. To wrap this up a little bit, we have the common area, building type, office. If you see here, it's very specific. So you can have office enclosed and office open plan. So we can get to the open plan, select it, updated. Then we can go to space type here and look for office, which is going to be enclosed. We have different spaces for different situations and different conditions. And now that we do it, we can save settings. Even if you want, you can come to heat and cooling loads and then click calculate. This will generate a report with different loads and conditions that it has. And this you can send it to the engineer so he can approve or review or use it for his calculations. Basically, it's this one.
Yeah, and then when we look at this, these are the reports, and these reports can be further edited with beautiful diagrams and callouts, etc. If you then go to GBS and or the other platform is Project Solon, then you can create really beautiful, informative client presentations.
So take this in mind whenever you go to work on an office, or just like you graduate or whatever, because the thing is that these elements are really good for speeding the process of designing and working with different engineers. Okay, so basically that's the assigning of spaces. You could even create a space schedule if you don't want to generate a report that is so big. Is there anything else here?
No, Miguel, because you just demonstrated very nicely the room and space and schedule alignment. This can now be further processed in the optimization tool, up in the energy optimization, and then sent to the cloud to update the GBS and the Insight. And when everyone goes to Insight360, then you will see where you are at that moment. Did you arrive already close to the carbon neutral benchmark standards of the AIA or not? If not, you can optimize the sliders in Insight360 with the recommendations take a screenshot, note it, or make a report, and then go back to Revit, to the settings, and do exactly what Miguel has demonstrated. And also you can communicate with manufacturers. You can call them and contact them and say, hey, listen, your wall component, I need a better R value, a higher R value, because otherwise I won't be able to achieve the carbon neutral benchmark from the AIA. And then you import that BIM Revit family into Revit, process, and override the settings and test it again. And this can be all shared in real time with any collaborating engineer and architect worldwide if you work in a 360 master file environment. Is that, Miguel, right? That's pretty much the nutshell.
Yeah.
No? Mm-hmm. That's the nutshell.
In this case, the facade is all glass, right? We could select a panel here. This is a grid system from Revit. It's a very powerful tool to create, basically whichever facade system that you want to do with a grid basic pattern. We can select the panel here, and if we go to system panel, we go the type, we can start seeing some information of it. So this is a average system panel glazed. We have here materials and finishes. The finish is, in this case, not loaded even. You could do it. Material is glass, just normal glass. The material also has some information usually that you can take into consideration. And then with analytical properties, you have the thermal resistance and the heat transfer coefficient of that specific material. If you are seeing this one, we have the mechanical and the strength of the glass. The glass can yield the strength of 479. Its behavior, thermal, and some other information here. So if you are seeing these two windows, you are seeing some analytical properties here as the type properties and some physical properties here of the material. Why do you want to know this or you want to see this? At least for changing, it's the minimum. If you go to a different manufacturer and they don't have the BIM models, which can happen here in Florida, you can come to these different options and start filling it by yourself. So at the end, you will have a really close to reality BIM family. If not, you can even upload from a manufacturer, a specific manufacturer. You can upload their family and just add it to the system, which is basically going to be here on type properties. You could duplicate these types, say glaze 2.0, and then here you could change the different materials, or you could change even if you want curtain walls, double glass, or an empty system panel.
Miguel, would you go back to the material properties?
Yeah. So material finishes, material glass.
Yeah, the properties you had. This one. Yeah.
You get to physical, and then you have a lot of information.
For example, if you just freeze that, what you all see there is fundamentally important, because just an example, if you take structural courses and you do calculations, which is mostly done on paper with some slides and presentations, maybe animation, but here within Revit, you actually are right in the integrated project delivery settings. So for example, if you look at mechanical and strength, you have all the modules, the ratio, the shear modules, the density listed right there. And the same for thermal. If you go up, right now we have physical, but we also have thermal. Then you have all the thermal properties and so on. Or when it comes to daylight analysis or electrical lighting analysis, you also have that information because it's all embedded. So if you guys are doing a lighting analysis, daylight analysis, and this is an office, and you have selected the wrong glazing, right, Miguel? With the wrong properties,
Exactly.
then you have a huge problem to achieve the 500 lux on your desk plane. Meaning you would have to go back and replace this baseline system panel glazing with a glazing type that has much better properties to match the daylight benchmarks that are required by building code or by any certification like LEED, Building Challenge, Energy Star, etc., etc. Now, when we talk about the physical strength, we are here in Florida, we have hurricanes. So the data sets that we have here embedded and also in the cloud, we can run this through robot structure, that's the plugin, and do the testing for the glass facade with these properties. And if the volumes fail, we can replace them again with a better manufacturer Revit family file that matches all the building codes and Hurricane 5 requirements. So this is a huge and powerful advantage, having these building information modeling capabilities that integrate all the millions of data sets in one master file.
Exactly. Which really translates the most thing that we can translate it on productivity on the work on the day by day basics is on a speed. It increases a lot of speed and communication between the different people around, and that saves a lot of time and misunderstandings.
Plus, Miguel, if anything goes wrong, we have always the recording, we have witness material, we have facts, and we can find the problems because it's embedded in these master files to do troubleshooting. And you can communicate worldwide if you have someone on a job site, let's say in Colombia, and you just dive into this detail and use the VRML, or any virtual reality tools. They can literally stand in front of the building and see the details. And Albert, you just did this in a big research years ago, right? Yeah, using BIM tools and standing in front of a building and seeing all the details on the iPad. Augmented reality. So all these capabilities we have today, it's fantastic, it's promising, it's exciting.